Welcome to yet another video on SRID Cloud. In this video, I want to talk about DHCP and redundancy. So the intention behind this video is to show that in a topology, more than one DHCP server can be deployed and connected, and it can provision IP addresses to the endpoints. And if one of the server goes down, the other server can pick it up and provide the IP address. So let's look at the topology. There are a couple of compute endpoints at the bottom. They are in two different VLANs, VLAN 100 and VLAN 200. And their IPs are 192.168.1.2 and 2.2. The respective networks are 192.168.1.0 and 2.0. And these two compute endpoints are connected to access ports on a switch. And a router is connected to the switch as well, and on a trunk port. The router is the 192.168.1.1 and 2.1. These two are the port channels on it, providing the gateway functionality for the VLANs. And this is the router where the IP helper address is implemented, so that if PC1 or PC2 want a DHCP IP address, then the router can forward the DHCP request to one of the routers at the top. So at the top we have a couple of routers, the router 1 and 2, and these two can be called as edge routers, and these two provide a similar functionality, the DHCP pool, and with exclusion IP addresses and all that. So let's get into the each of the endpoints and then look at the runtime configuration. So first of all, I would like to go to the core router, the router right in the middle, and look at it. Let's look at the runtime configuration. There are a couple of VRFs, VRF A and VRF B. They are deployed to handle the isolation of the VLANs. And there is a port channel 1, and this has got a couple of VLAN specific port channels, 1.100 and 1.200. And if you noticed, these two are in their respective VRFs. And the IP address of these port channels are also, as I mentioned earlier, the gateway for their respective VLANs, 192.168.1.1 and 2.1. And the IP helper address configuration in these two port channels are multiple. There are dual IP helper addresses here, 172.16.1.1 and 1.5. 1.1 is the IP address of the interface going to the router on the left at the top, and the other router is 172.16.1.5. And there is no and there is a port channel 2, of course, and this is also to isolate the traffic going towards those top routers, the edge routers, the port channel 2.100 and 2.200, and they are in their respective VRFs as well. And the gigabit Ethernet 1, 2, and 3, they are not actually, the gigabit Ethernet 1 is used. That is where the port channel 1 is implemented, and gigabit Ethernet 2 is where the port channel 2 is implemented. So these are the two interfaces on south and north. And that should be the configuration on this router. So most importantly, there are a couple of port channels on the southern side of this router, and on this I have configured the helper address 172.16.1.1 and 1.5, both of them. So if one of them is down, the other one should receive the DHCP request and return the IP address back. So now let's look at the router on the top, the left one, 172.16.1.1. And let us look at the runtime configuration. As expected, there are a couple of VRFs on it, and there is a DHCP excluded address configuration here as well. The intention here is to ignore the first 100 IPs of the VLANs. So the first IP that should be provisioned is 192.168.1.101 in the case of VLAN 100 and 192.168.2.101 for the VLAN 200. And there are a couple of DHCP pools defined in their respective VLANs with the corresponding default routers. And if I look further down, there is a port channel on this router as well to segregate the VLANs, one for VRFA and one for VRFB, and both carry the same IP address 172.16.1.1. This is the IP address I mentioned in the helper address in the core router. And there should be nothing else. Oh, I did not implement any BGP or any route distribution protocols between the core router and the edge routers. So to keep things simple, I created a default route, a static route, I should say, a static route from the edge routers all the way to the VLANs in the south. And that's it for this router. So we should see something similar in the right side top router as well. But let's take a look at it as well. So it should be very identical. There are a couple of VRFs here, and there are a couple of excluded addresses. Everything is duplicated in terms of DHCP. The duplication of the configuration between the routers at the top. So there are two VRF pools, identical pools, and there is a port channel configuration as well. And here the IP address is 172.16.1.5, and this is the second helper address I configured in the core router for DHCP purposes. And of course, these are the two static routes. I could have used BGP or anything else here, but to keep things simple, I'm using static routes. So that's it on these two edge routers. And now let us go to the PC1 and simply clear all the IP configurations here, so that if I say show or show IP, there is no IP configured on this PC at all. So now I'm going to say IP DHCP. This will make the DHCP functionality to go out and look for a DHCP server and perform the DHCP discovery. In this case, the DHCP discovery will be attempted on both the routers, but actually the only one of them will respond, and the PC will get the IP. So let's see. So it has successfully sent the DHCP request and got the IP as well. So let us say show IP. So this IP 192.168.1.101 was configured by the left side core, left side edge router, because the IP address of the DHCP server is 172.16.1.1. And now let me go to the second compute endpoint and do the same thing over there. Yeah, got the IP 192.168.2.101. Let me do show IP. And if you look at the DHCP server, it got it from the same top left side router. So now, couple of things. You may ask me, why not VRRP? So why add two DHCP helper address configurations in the core router? Instead of that, why can't you define a VRRP between these two routers and call it as virtual IP 172.16.1.3 and use this 172.16.1.3 as the only helper address configuration in the port channels in the core router? So why can't we do that? So I'm going to show that that does not work. So let's change the configuration. Let's go and define the VRRP. So let's go to the first router and let me do show run. So on these port channels 1.100 and 1.200, I'm going to define a VRF. Say config T and int port channel 1.100 and say VRRP 1 IP 172.16.1.3, and similarly in the int port channel 1.200 and do the same thing. Okay, now if I do show run, I should see the VRRP configuration on both the port channels. Now I'm going to do the same thing on the right side edge router as well. Config T and then int port channel 1.100 VRRP 1 IP 172.16.1.3, and similarly in the int port channel 1.200 and same thing. So now we have established VRRP on both the VRFs on the routers. Okay, now let's look at it just to make sure it is done. There it is. The VRRP configuration is in it. So now let's go to the core router and replace the helper addresses, the couple of them, both of them, with only one using the VRRP. Show run. So in the port channel 1.100 and 1.200, I'm going to remove these helper addresses and then replace it with 172.16.1.3. So config T and then let me do the int port channel 1.100 and then just say no IP helper address 172.16.1.1 and then no IP helper address 172.16.1.5 and then IP helper address 172.16.1.3. Similarly in the other port channel, and port channel 1.200, no IP helper address 172.16.1.1, no IP helper address 172.16.1.5 and IP helper address 172.16.1.3. So now let's look at the runtime configuration just to ensure. And here it is. The helper address is now pointing to the VRRP IP address 172.16.1.3. Okay. So with this, let us go to the PC1 and clear the IP first of all, and then make sure show IP does not show anything, and this is IP DHCP. As you can see, it is struggling to get the IP because the DHCP request has gone over there, but the return trip did not happen. So let's go to the other PC as well and show the same thing. Clear IP and then IP DHCP does not get it. Okay, so now let's do one more thing. I want to attach Wireshark to these interfaces and then look at it. So what I'm going to do is right click on this link to the first edge router and then start capture and it is coming up now. So I'm going to limit the request to DHCP only. I think it should work. I hope so. And then I'm going to attach the Wireshark to the other side as well. I think DHCP should work. Let's see. Okay, with these two on, now let me go to the PC1 again and then do the DHCP request. Clear IP, and should not be any IP in it anyway, but IP DHCP. As you can see, the DHCP discover is gone to the right side, 172.16.1.5, with no response whatsoever. So there's absolutely no response coming from the router if the helper address is a virtual VRRP. So this is exactly what I wanted to prove in this video. So now let me go back to the old style. I'm going to remove the VRRP helper address and replace it with the two IPs of the routers in the core router. So let me go to the core router again. And let me bring up the port channels 1 and 1.100 and 1.200. And I'm going to say no IP helper address 172.16.1.3, and I'm going to say IP helper address 172.16.1.1 and IP helper address 172.16.1.5. And similarly in the other port channel 1.200, I will do the same thing. So no IP helper address 172.16.1.3, and I'm going to add IP helper address 172.16.1.1 and IP helper address 172.16.1.5. Okay, now let me go to the PC1, and that should work now. So let us say clear IP in IP DHCP, and this time he's getting the IP. I hope. Yes, he got the IP. So now there's one more thing I wanted to show in this video. The purpose of this video is to use not to use the VRRP for DHCP redundancy. So the purpose part of the purpose of this video is DHCP redundancy. So now I'm going to shut down the router number 1 on the left side. Now if I do that, the second router on the right should provision the IP address to the PC1. So for that, let me go to the edge router number 1. Instead of shutting down the entire thing, I'm going to shut down the port channel only. So config T in port channel 1.100 and then say shut. And then if I say show IP int brief, one of them is down. So now let me go to the first one, compute, and then clear IP. So and then I say IP DHCP. Now it should get it from the other DHCP server. And they show IP. It got it from 172.16.1.5. Okay. So this is the this is how the redundancy works, and you set up the DHCP pool on both the routers, and then on the core router where the decision is taken in terms of where to send the DHCP request to, the IP helper address configuration, you mention both of them, and the router will take care of picking up one of the two. If one of them is down, then obviously the other one will will be used. But if both of them are on, only one of them will receive the DHCP request, and then you can get the IP address provisioned. So in summary, the VRRP virtual IP does not seem to work for DHCP. I'm not sure why not, but obviously we saw that it's not working. I think VRRP IP is more meaningful for the gateway purposes, where the return trip is configured at the respective edge routers, either with a static route or with the BGP or whatever the route distribution protocols. That ensures the return trip. But in the case of DHCP, the router has to decide, probably is trying to send the IP provision back to the VRRP IP, not their respective IPs. So maybe that's what's going on. Maybe that is why it's not working. So the lesson is VRRP cannot be used for DHCP purposes, but for other purposes like gateway purposes. So I hope you enjoyed this video, and as much as I did preparing it, and I will see you all in another video at another time. And bye for now.